All right, our final example with applications of polynomials. So it says the height, length, and width of a small box are consecutive integers. So this is going back to your grade 9 skills here. Consecutive integers are, first of all, numbers without decimals, and they're consecutive. So 1, 2, 3, for example, 4, 5, 6. And the height is going to be the smallest number. If the length and width are increased by 1, and the height is doubled, the volume will increase by 120 centimeters cubed. Determine the original dimensions of the box. So I'm going to give myself a picture of a box to start with here to help me visualize what I'm dealing with. So there is my box, and I know that I have length, width, and height. So height, width, length. And I don't know any of them. I don't know a value for any of them. So I'm going to do my let statements. So it says that the height is the smallest of those. So let H represent the height of the box. Oops. I'm just going to keep making it just one word apparently. Box. All right. Now going back to the statement, it says the height, length, and width of a small box are consecutive integers. All right. So that being said, if h is the height, then what will width be? Width is going to be the next number, and I said consecutive integers were 1, 2, 3, 5, 6, 7. So h plus 1 is going to be the width. Again, please take note of the let statements, the requirement for these types of problems. And then the length is going to be the next one, which would be the height plus 2. So represent the length of the box. All right. So that means that the volume of the original box, length, width, and height, so volume of original box would be, do they give us a value? Nope. So we know volume equals length, width, and height. So just replacing it, we would have h plus 1, h plus 2. So there is our original volume. So I'm just going to put a box around it. I don't want to lose it. Now, in the second part of this, it says the length and, if the length and width are increased by 1. So the length and width. So those are my values here. So here's my length and width, just so we know where we're talking. And it says right here, length and width are increased by 1. And then the height's doubled. So height's going to play a role in here too. The volume will increase by 120 centimeters cubed. So now, the new box. All right. So we know that the volume is now going to be 120. It's going to be increased by 120 centimeters. And we know the height and so on and so forth is doubled. So our new volume of the new box is going to be the original volume plus 120 centimeters cubed. Okay, so that V comes from right here. V is the original volume. So it's the original volume, and we're going to add 120 cubic centimeters, and that will give us the formula now. The height got doubled, so now it's 2h, and both the length and width were increased by 1, so now it will be h plus 2 and h plus 3. So this is the volume of new box. All right, so when I'm looking at this question now, I have the volume of the old box and the volume of the new box. What's common to both equations? When I look at it, this equation has a V, and this equation has a V. So I'm going to do a substitution. I'm going to replace V with the original volume. So I'm going to take that second equation and I'm going to replace it. So I'm going to rewrite the second equation equals 2h, h plus 2, h plus 3. And I'm going to replace that v with this v up here, which means I would have h plus 1, h plus 2, plus 120 equals 2h, h plus 2, h plus 3. All right, so there's the new equation for us to work with. To solve an equation, it's got to be equal to 0. So I'm going to move everything to the left side. This is really one term, so I'm going to subtract h plus 1, h plus 2 from this side, and I'll subtract it from this side, h plus 1, h plus 2. I'm going to subtract 120 from both sides. So I end up with 0 equals 2h, h plus 2, h plus 3, minus h plus 1, h plus 2, minus 120. And again, you're thinking maybe, do we have to simplify this equation? No, absolutely not. If we're going to use technology, once we have it in the equals 0 format, we can enter this into the calculator. So bringing up my calculator, telling it to turn on, because it's not actually on batteries. I'm going to enter in the equation. Now, my h's have to become x's, so I'm going to enter it in exactly as I have it written. So 2x, bracket, x plus 2, bracket, x plus 3, bracket, I'll just bring it over here now, minus x, bracket, x plus 1, bracket, x plus 2, bracket, minus 120. So the calculator will handle that exact equation. Go to graph it. I got to change my window because the previous settings are absolutely no good to me. So let's go, I'm going to go back to the negative 10, 10, negative 10, and 10, see if we can see anything. So here we go. There's 1. I don't see anything else. So at this point, I'm just going to increase my x values this time. So I'm going to change my x max. I'm going to go up to 50 now to see what happens. Excuse me. So it crosses once. Okay. So now I'm going to extend the window from negative 100 to 100. I'm just double checking to see it only crosses once. So from negative 100 to 100, I only see it crossing once. So I have to make the conclusion that it only crosses the x-axis once. I mean, we can extend the window out as far as you want. We can go up to 1,000 if you want to double check. But I'm feeling fairly confident that it doesn't cross again. So I'm going to bring the window down again to negative 10 to 10 so we can see where it crosses that once. So there's only going to be one solution. That's the assumption I'm making here. Okay. So solving, finding the 0. Move it a little bit closer. Where are we here? Here it comes. Whoops, missed it. So there I'm on the left side. Move it above, I'm on the right side, hit enter, and it looks like it's exactly 3. So therefore, h equals 3. So there's only one solution, okay? So based on graphical evidence, there is only one solution. We're looking for the dimensions of the original box. So you go back to the let statements. The let statements tell you what everything is. Okay, this is how you figure it out. So h is height. So h is height, so it's 3 centimeters high by, if I move up, again, h plus 1 is the width. So 4 centimeters wide by 5 centimeters long. So I'm just using the let statements to help me out. So that's the only possible solution for this scenario. All right, so there we go. So try, I think there's 10, it's only 6 word problems to try. You're practicing with the graphing calculator, and you're practicing setup. So hopefully yesterday or the previous lesson you got the graphing calculator figured out. Now we need to work on setting up these cubics. And the second example is definitely the more challenging or the harder one than the application questions you're going to see today.